Thanks everyone for dialing in. I know we're still a minute or two early, and maybe we can give people a minute or two after the hour to dial in. But if anybody has any questions, comments, or suggestions, we can certainly start talking now.
Hey, David, could you share the YouTube live stream if it's ready?
I will, yeah, just 1 second. And there's a chat over on the live stream page, there's a chat, so we can keep an eye on that to see if there's any questions.
Okay, great.
And Vipin, maybe one thing you might want to do, or Darman, while we're giving people 1 or 2 minutes to dial in, do you want to maybe just speak about the group for anybody who's new, and then after a couple more minutes, then we'll just hand it off to Nima? Vipin, you're on mute if you're trying to speak. And I did just drop the link to the live stream in the Zoom chat. Okay, Vipin's saying he has a problem with his mic. That's fine. I'm seeing if Darman is on. Darman, would you like to, it sounds like Vipin is having a problem with his mic. Would you like to maybe introduce, not to put you on the spot, but would you want to maybe just explain to people who are new to the call what this group is, and then after an introduction and setting some context, we can then hand it off to Nima?
Yeah, sure. Yeah, sure. Thanks, David. And yeah, good evening, good afternoon, everyone. Very excited to see you all here. And yeah, although I'm pretty new to this group, but very excited to be here. So as we all know, this group is primarily for a special interest group for telecom, where where we have the like-minded and the experts from various parts of the world who are interested in kind of bringing in new ideas or working together and research what we can do in this telecom sector with regards to blockchain and new areas of interest, including the 5G, IoT, the interconnect, and all that. And so it's a special group wherein everybody is invited, and more the merrier. Basically, we kind of meet fortnightly and then discuss on the projects that are going on. The idea is to kind of bring in newer ideas, put together some white papers, research on the ideas, and then bring out some standards in this area, wherein we can actually evangelize and put together some standards for better adoption of blockchain in telecom space. Yeah, so that's primarily the thing. And today we have a very exciting talk from Nima, wherein probably I would let maybe David or give that introduction and get started over there.
Great, thank you for that, Darman. And one note, just to let everybody know, I did drop a link in the Zoom chat. If you are new to this group and are interested in joining the discussion beyond this call, we have an open forum where you are welcome to join. We have a mailing list and then we have regular calls. If you subscribe to that mailing list, there's a link in the chat. You're welcome to introduce yourself, ask questions of the group, join in discussions. If you're on the mailing list, you'll also get notified about upcoming calls. We do meet regularly. And we do have various guest presentations. So if you want to find out about those, just feel free to sign up to that list. And with that, let me introduce Nima. He is a longtime member of this group. He recently offered to share some of the research that he's doing, so we appreciate his time. And today he's going to share about decentralized 5G marketplaces based on Hyperledger Fabric. So with that, I'll hand it off to Nima.
Hey, thanks, David. Thanks for the introduction, and thanks Vipin and others who were kind of helpful to get this organized and kind of reach out to a bigger crowd about the research. So this is Nima. As David mentioned, I've been with the Telecom Special Interest Group for a while now, almost since the beginning. We are mainly focusing on telecom use cases for Hyperledger platform, and we're trying to figure out where we could actually use Hyperledger technology to kind of facilitate certain processes in telecommunications industry. So today I've been really I'll be talking about a problem that it is related to the research that we've been doing in the research center, regardless of the blockchain work. So this is mainly really about the resource allocation problem for the next generation of the communication networks and mobile communication networks, which is the 5G. So before really, so you can all see the slides, I guess, right?
Yeah, I'm seeing them.
Yeah, great. So really, before jumping into the main topic, I'll briefly introduce what is going on with the 5G really infrastructure battle at the moment. So what 5G brings, in addition to the bandwidth upgrade and the quality of service upgrade and so on, is really that it attracted a new variety of services. So this includes smart health, a smart vehicle, a smart road, the smart cities, and all these technologies, as modern as they are, but they still require plenty of bandwidth and some very strict requirements in terms of latency and so on, which all relates to the infrastructure that has to be deployed to be able to support these services. And as in 5G, as probably most of the people here know, that really means very dense deployment of 5G equipment, radio kind of towers, and so on. So this really means that the smaller and more innovative service providers who want to provide kind of very creative services over the network, they won't be really able to kind of get the resources and the infrastructure they'll need to join these networks and serve their customer base. So these include really the radio spectrum, the base stations, the fiber, and all the equipment essentially. So this really makes it very important for us to enable the secondary usage of 5G network infrastructure, meaning that as it's been the tradition in telecom networks, the bigger operators do share their resources with others. So currently, the way it's happening is over very long-term kind of contracts between these network operators. But what we see is that those kind of contracts are not going to be sustainable for the 5G network. So just some examples of the resource sharing, the secondary resource sharing we're talking about in 5G. So this could be radio spectrum sharing, the secondary radio spectrum sharing. So the primary users of the spectrum do the auctions with the governments or the spectrum authorities, and then they give away the certain chunks of the spectrum to other users, to smaller operators and so on. The same with 5G network slicing, where you actually create the slices of the network with certain requirements, and then you can dedicate these different slices to other users and so on. Again, with optical access networks, for example, PON networks, these are also kind of networks that could be shared within multiple operators and in the secondary resource sharing model. So this slide is really what was trying to tell is that the technical infrastructure is out there, and there are the most major standardization bodies like FCC, 5GPP, Broadband Forum. So these are all kind of already laying out the technical kind of infrastructure to enable this kind of dynamic secondary sharing of resources. However, really the market is not really there, as in as I mentioned before, these long-term contracts are not automated, so they still depend on very kind of exhausting negotiations between these operators, and so we are really trying to fix that. So we essentially, based on the expertise that we had in the research center, we picked the 5G slice brokering problem to kind of try this marketplace kind of Hyperledger solution upon. So here you kind of see how the scheme of the slice brokering example in the 5G. So this is the centralized model where you have the MVNOs and OTTs and infrastructure providers in the left-hand side. So assuming that they have some idle resources, and then you have on the other side, on the right-hand side at the bottom, you have the MVNOs and OTTs who are in demand of certain resources that are going to be dedicated to them as a slices. So these slices could include some RAN, computing, storage, could be a combination of each. And in the middle, you have the slicing manager or orchestrator and the slice broker that is a kind of a part of that management system, where in our case, we are using auctions as a market mechanism to really allocate those idle resources to the people who are kind of bidding for them. We'll talk about that a little bit later on. So all good so far. Let's say previously, conventionally, you would have a centralized kind of infrastructure provider, maybe a government entity, or maybe a major operator that all the smaller operators trusted. And then they would usually take care of this market negotiation and market mechanism, and they would run this market mechanism, and then everyone would be happy, everyone would be dedicated their resources, and all is good. But now we're seeing a market model with the 5G that you don't really have that luxury anymore. So now you have MVNOs and VNOs who actually kind of own all the infrastructure, but they also contribute and also exist in that same infrastructure and operate on that same infrastructure. So the other operators see that operator as their competitor, and there is no really natural incentive for them to trust that particular central operator as an intermediary to take care of all the market allocations and so on. So our idea was to use blockchain technology here to first assure consistent record keeping, and also to kind of find a distributed way of conducting the market mechanism. So we did the implementation using Hyperledger Fabric. So what happens, so every transaction, which is the auction transaction, is deployed as a smart contract, and it goes through the standard transaction flow of the Hyperledger Fabric use cases. And then, so I won't really go into details of this, but this is essentially the auction algorithm, which is not very relevant to this talk. But all I would say about it here is that this is an auction which is a sealed bid auction, meaning that there is no back and forth bidding. So once all the buyers and sellers submit their bid and ask prices, that's it. So that goes through the algorithm, and then whatever the outcome is, so that will be executed, and that will be written on the ledger. So essentially, we are seeing the network slice as a commodity here, and for purpose of this research, for now, we are defining the slices kind of as in templates, and then the users can buy multiples of that particular slice unit. Again, so another really way of showing how the system works. So really, for our reasons for choosing Fabric over other available platforms was the modular design. So if, let's say, we want to just take out the consensus protocol now and replace it with some other consensus protocol that is kind of fits better our industry, it's quite easy to do. It's open source, and it has a great community, and it's not just simply like any other community. As you can see in Telecom SIG, we have a great group of experts here from industry, from academia, and we exchange ideas, and we actually kind of as others mentioned, we actually write white papers, and we kind of do research essentially here together. So yeah, join us if you want. So again, another reason is because it's permission, and it's, as we know, it's the operators, network operators, telcos are quite kind of private about their data and about their users' data. And then the built-in membership identity service is quite helpful here, and it could be actually integrated with other kind of membership identity services that an operator would have. This is also very important for us: the high transaction throughput and lower latency. So as you know, latency is really the trickiest part in 5G, and the numbers are really very strict. And also the multi-channel support, again, that's very beneficial when you say you have 20 network operators who want to do this trade with each other, but they don't necessarily want to reveal all the data or all the information with all the other operators, so they can just create their own channels and kind of talk on that channel with a smaller group of operators. Again, so these are really the transaction flow. So this is how our deployment works. So we use a public cloud service. So we really just deploy the components on different VMs that represent the different organizations. We use Docker Swarm to orchestrate the kind of Hyperledger Fabric Dockers. Again, we use some other technologies to do the benchmarking. We use Hyperledger Caliper to benchmark. And then we use Grafana, Prometheus, and some other tools for monitoring of these kind of use case that we have here. So this is a little bit older kind of results figures here. We essentially achieved transaction throughputs and latencies that were already good enough for the the numbers that people kind of speculate that will be required for this slicing use case in 5G networks. Again, some results, I won't really go into details of them. So essentially, the conclusion was that we can meet the envisioned timescales for 5G provisioning and deployment. What we are currently working on, it's taking lots of our time here, is really trying to, so as I mentioned, with the slicing use case, we are already meeting the required demand. But for having this distributed marketplace platform to be used for many other use cases, we could try to see how much it scales really. So this is really the numbers that we're achieving at the moment. So the SUTs are the systems under test. So as far as I remember, the SUT1 is 2 organizations on 3 VMs. So 2 VMs are hosting the organizations. They're each 32 cores and similar RAM. And then you go forward, and then you have 5 organizations, again, with different hardware. And then you have the transaction throughputs that we've been able to achieve up to 400 at the moment with the current auction algorithm. And still kind of the latency lower than 1 second. So that's pretty much it from my side, and I hope that it was useful for most of you guys, and I'm ready to take questions if there are any.
People are welcome to drop a question in the chat, raise their hand in the Zoom, or just unmute and ask.
Yeah, I think there's already one question on the chat from Brett. Are you implementing oscillating simulation for that radio frequency?
Yeah, so I think Brett is referring to some interference-related topics here. So the reality here is that we have not really integrated the solution with any real kind of telco network, running telco network. So here we didn't really worry about the interference with other networks and so on, or inter-slice interference and so on. So no, so this is not really a part of this research, but we are at the moment trying to find the right kind of SDN controller for these RAN networks that are already enabling network slicing, and we're trying to integrate the solution with those, and we have really future plan to extend this work.
This is Brett Carpenter. I'm pretty sure that what we want to contribute as a group when we become a member of Hyperledger, right now I'm just the Hyperledger organizer of Troy, Michigan, is that we are now in contract with RAND Worldwide, and we are going to be manufacturing, or rather 3D printing antennas. And so with that being said, there are many solutions to being able to bring a simulated reality into the actual, actually implement it into the real world. And so right now I've been getting all of my documents from RAND Worldwide. And I think at some point in time I want to present, but I do think that once I'm able to make a clear presentation, that it may be useful in what you're accomplishing. Thank you.
Hi, Nima. Can you hear me? This is Vipin.
Yes, Vipin. Thanks.
So thanks for the presentation. And I have some questions, right? Okay, let's take one by one. So let's say, what is slice for me? Let's suppose, right? For example, there's a network operator, let's say telecom operator 1. And if I say what is slice is like, let's suppose this, let's say this, okay, take this example, let's say some IoT sensors connecting and all these things. And within the domain, we have, let's suppose SDN controllers as well. So this brokering thing is like, and this whole system, I'm hoping that this is like a consortium of let's say 2-3 operators, right? And let's suppose one telecom operator wants to give some kind of um, some kind of idle slice to some other operator, let's say. So in this whole system, what we are trying to do is like, we want to automate this kind of brokering, or we want to audit, or we want to use blockchain so that this brokering kind of things can be easily done between different operators or in a consortium. Means I want to understand what is the goal behind all these activities.
Yeah, thanks, Vipin. So as I said, so first of all, the brokering itself, so slice brokering is not the topic that we have kind of came up with. So slice brokering has been there already, and it's been technically implemented, and it is actually being kind of used in by different network operators at the moment. And there are actually SDN controllers and SDN orchestrators that allow this to be kind of executed on certain kind of RAN situations or with computing and the storage, so that everything is there, the technical from the technical side. So what we are here doing is that although that the brokering is already automated, but it's automated with the assumption that you have that central intermediary who takes care of execution of these kind of whatever market mechanism is there. So if you go online and search for these slice brokering or spectrum secondary market kind of sharing, you will see plenty of algorithms that are used to kind of facilitate this trade. But here, what we are trying to do using Hyperledger is to get rid of that intermediary for the trustless situations where you don't really trust that one particular central operator. And so I know the way you say is that it's going to be 2 or 3 operators, but that's not really the way that we see it as. So the way we see it is that it could be 100 operators. They don't necessarily have to all be using the network at the same time. So you could have one service operator who doesn't really regularly serve in a certain geographical region, but for some reason, maybe there's a match in a stadium, and they have to serve that particular group, and they have to come into this region, to this area, without having any infrastructure deployed, and they can just initially is essentially just attach to this network by buying some resources, idle resources from other operators. So that's really the idea. If I was able to answer your question.
So where this nodes are, like on SDN controllers or somewhere else?
So, I mean, technically, these nodes are supposed to be hosted by those operators who are using them, right? So, if I have a peer, or if I have orders or whatever, I have to be able to kind of host them in my own servers or my own kind of data centers and so on. So, from the architecture point of view, that really depends on how you are kind of organizing your network. Uh, with the numbers of transactions and so on that we are expecting, and we are kind of pushing for, you will need your own kind of cluster, whether if it's a very powerful server or a Kubernetes cluster or whatever. So this won't be really a very small kind of network function that sits somewhere in the controller. So you will need a kind of a decent enough infrastructure, computing power to be able to run these, right? But then, if that's not really the case, you can actually have, for example, the Xilinx boards that the previous weeks they've been talking about them here in the Telecom SIG. So they could be used to be kind of integrated into those controllers and kind of work as a smaller nodes within the controlling environment.
Okay. And could you show me this last slide where you were showing the results, like reliable slicing in 5G networks? Yeah, this one. So, so this SUT1 is like you are using, let's suppose, two operators. SU2, like two, you are using different operators. Means if I assume it, like let's say different two VMs in SU2, we have 3 or 4 VMs, and then we are trying to see, what is this? Is it latency, throughputs, and what is the result of this? Means what do you want to show this in this? What is the output of?
Essentially, what we're really trying to show here is we're trying to show what are the kind of the limits here. So, as I said, for the slicing use case, 100 transactions per second, which means 100 auctions per second, and below 1 second latency is perfect. It's more than what we need. So that could really meet the requirements of the 5G network slicing. But then we're looking at other use cases that could use this particular distributed market model or the marketplace that we are kind of. So that's really the main product that we have here, right? So let's say in my own previous work that I've been working before the blockchain, so in pawn networks. So in pawn networks, these kind of frames or pawn frames or kind of the scheduling frames are scheduled every 125 microseconds. So what that means is that what we initially designed this auction algorithm was for those particular networks when we wanted to share them with multiple operators. So obviously back then we weren't really working on blockchain. We were just trying to see how these how we can actually design an algorithm that would respond to such a high frequency kind of algorithmic market mechanism. So here, so if you want to kind of consider such scenarios for those numbers, so you imagine 125 microsecond per transactions. Transactions every 125 microseconds. That means 8,000 transactions per second. And okay, so I mean there are kind of some papers and some work that shows. Let's say there's Fast Fabric. They claim that Fabric can support up to 20,000 transactions per second. Well, obviously, that's not the standard Hyperledger Fabric. So they do lots of improvements there. So they take out all the nodes from the Docker containers. They put them straight on the system itself. They store the blocks or the transactions on RAM, let's say, instead of the disk, and many other improvements. And they claim that they can achieve those numbers. So and they actually illustrate that. So what we are trying to achieve here is to see what our kind of smart contract that is the auction can achieve. So here the best number, so and this figure is really, I just generated it maybe an hour ago, so this is really the latest results that we are getting. So we haven't been able to reach more than 400 transactions per second, and that's quite a big number if you kind of consider it in business terms. But it's still, if it's going to be used for such scenarios that I mentioned, there is still some way to go. And really, so the numbers that you see on the top are the latency values, and the latency values and the throughput values are written at the bottom.
Yeah, thanks, Nima. I think I also worked with this 5GPP kind of things, and we worked on network slicing, and yeah, that is like a very good use case because I worked on end-to-end network slices, and these slices with SDN controllers, we had one orchestrator, and we used some kind of orchestrate. We used blockchain and kind of orchestrator. I think maybe next time I can show that. Yeah, we can discuss over this. But we have more questions here. Brett is asking SQLDB. I think I hope it's Hyperledger, so it's NoSQL things. Yeah, Nima.
Yeah, so these experiments are done using LevelDB.
Yeah.
So we weren't really bothered a lot about very rich query language or so on. So we were essentially just trying to kind of choose the fastest and quickest option.
Yeah, even every Hyperledger, even every blockchain, most of the blockchains are using like LevelDB, CouchDB things. So yeah. So we have one question from Mazda. He's asking, with centralized Procre entity, actual sharing of slices resources is guaranteed. Can we have a guarantee mechanism here?
Yeah, so that's a great question, Mazda. That is actually really the next step that we are taking towards this work. So, and we do actually have a SLA subgroup in Hyperledger Telecom Special Interest Group, and it's been idle for a while, but we actually encourage people to join and contribute work there. So yes, so essentially the smart contract that we have here is the auction and market mechanism smart contract. But this smart contract could be easily extended to kind of monitor way more features. So you can essentially, let's say, define availability there, and let's say you want 99.9% availability for the network slice that you have acquired. And then you can have certain measurement points set up on your network, and those values could be recorded on the ledger, and then the smart contract could actually enforce those requirements that are essentially in an if and else. So the smart contract could be just if and else. So if below 99.9% over this time range, let's say penalize or any other function that you want. The same, it's not just limited to availability. It could be kind of let's say if the seller operator is kind of committing to 100 millisecond latency, you can also put that as an option there. So in the smart contract, you can check whether if the latency is going about that amount, and then you can invoke certain transactions based on that.
Yup. Thanks, Nima. So we have very interesting question here from Lam. He's asking, how do you define the network slice in your network with Hyperledger Fabric?
Yeah, so thanks, Lam. So as I mentioned before, I'll try to bring the slide. So here, our definition of this slice, for example, is just a logical kind of piece of code, right? So there is no, so we haven't really connected this to a RAN controller. So essentially, a slice is 1x RAN, 1x computing, 1x storage. So that's the template. So this is 1 unit of a slice. And then this 1 unit of a slice is the commodity that we are trading here in the market. So let's say MVNO1 bids for 30 units of network slice, and that and with a certain kind of amount of money that he's willing or she's willing to pay for this particular amount of slice resources. That being said, this is the most kind of simplified scenario that we have. If you want more sophisticated market mechanism, they are available. So the auction mechanism we're using here is a double auction, is a multi-item double auction. But you can go further. You can use combinatorial auctions that actually allow, kind of gives you more freedom to actually, let's say, source this slice from multiple operators. So you can get your RAN from one operator, you can get your computing from another, and then your storage from another, and then kind of build your slice upon that. So yeah, so that I hope that really answers your question.
Thanks, Nima. So as I understand, so each slice will be a kind of an asset in the network, right?
Yeah, I mean, again, so I'm not really sure how this would translate into actual slices in the controller, right? I just know that it would be translated because these systems are already working just without the blockchain, right? So the infrastructure is there, so the technology is there. So yeah, I mean, I assume using the REST API, probably you can actually transfer this information, or the controller could read this information as queries to the state database, and then when it could read that, let's say in this period of time, operator B has gotten this amount of resources from operator X, and then they can do the allocation part there.
Thank you. Actually, I just have a suggestion. That how do you think about if we consider each slide will be one channel in the Hyperledger Fabric network? Is this possible? Yeah, sorry for taking too much time.
I mean, I don't really see a reason for having one channel per slice. I mean, I would understand if we have 10 operators in the network. I would understand having 10 channels, right? So one between each operator, let's say, or well, that's actually more. But yeah, anyway, so I can understand that, but I don't really see a point, because initiating this channel on the ledger, it takes some time, and it takes configuration and so on. I don't really see why we would need a channel per slice.
Okay, thank you, Nima. Yeah,
you're welcome.
We have one more question, but I don't know what is asking.
Hi,
Control tower ciphertext. Is this?
Hi, Vipin.
Could the control tower ciphertext maybe be applied with this solution?
Yeah, I'm not really familiar with. Sorry, yeah, I'm not really familiar with this.
Well, then I'm going to make a statement. I do think that would be an interesting path to go down, is the control tower ciphertext.
Could you explain something? Like, this is very new to me as well. What is this, Brad?
It has, well, with AWS, it was something that I was going after for what we were essentially inventing. And so the control tower is solely owned in Amazon by Bezos. So there are other control tower applications that are available. And if I I think that I'll probably need to go into a deeper dive to explain myself, but you can Google search ciphertext control towers, and I think I think I would need to organize myself a lot more to be able to make sense of it. I've written pretty extensively about it. I just have to go back to my research, if you don't mind.
Yeah, yeah. Okay. So I think we have Ahmed as well. I think he's raising his hand. Yeah, Ahmed,
Yes.
hi.
Hi, Vibin. Hi, Nima.
Good.
So yeah, I got a couple of questions. So first thing is related to this performance figures, which is really interesting. Probably what I see maybe missing, or maybe I didn't catch, is that how different other configurations, let's say endorsement policy, number of channels, etc., would affect this, or bring the numbers up or down, because with endorsement policies that would require more validations from different peers. It's expected that this performance figures will, if it's an OR policy right now, it's expected that it will go down. So which endorsement policy you have used, Nima, for this mainly?
Thanks, Ahmed. Yeah, so that's a very, very kind of deep question. So the endorsement policy here is N out of N. So
what, sorry?
that is N out of N.
N out of M out of N.
No, N out of N, which means
okay, so
all the organizations have
peers,
to, the peers have to essentially endorse, right?
Mm-hmm.
So that's like the max you can get.
Yes.
And we had to really choose that because we're talking about trust here. So we are not just talking about kind of points of failure. Mm-hmm. We really want every single operator to execute this auction, and we want all of their results to be the same. So that's why we actually chose the N out of N. Regarding the channels, for now, we only have one channel. Mm-hmm. Because we are not really implementing the private data part, so that's not really our concern at the moment. More interesting thing for us right now is the block sizes and essentially the block configuration.
Yeah.
So these results are mainly achieved by 50 and 100 block sizes. I have been experimenting with from 10 to 400 really, and it's been actually frustrating because I've been trying to kind of play around with the block sizes and achieve higher transaction throughputs, but I haven't been able to actually. So 450 for now, at least, has been really the highest throughput that I've been able to achieve with reasonable latencies, right? So I mean, once you really hit the threshold of your network and of your system, there is really not higher you can go, and the latencies start to go crazy. And interestingly enough, thanks for actually bringing this up. At some point, I've been really realizing that it doesn't really matter how much processing power you dump into your system. So I was going mad actually, and I was trying to use like 128 cores per each kind of peer and so on. But I mean, at some point, those resources really don't matter anymore, and you kind of reach the limitation of the fabric components themselves. So again, there's as I know that you have a deployment experiment from the previous use cases that we've been working on, and actually it's becoming really difficult to kind of take into account all these configuration metrics and trying to really reach kind of find out what is the kind of the threshold that you have, what is the capacity of your network. So recently I've been so the Caliper project, I'm not sure how familiar the people in this group are with. So they have enabled kind of extra metrics to be exposed from their benchmark tool. And I actually recently kind of created a Grafana dashboard out of the metrics that they expose, and that's been quite helpful. So that actually helps you to see exactly when your experiments are running, to see when your transaction throughput cannot keep up with the traffic, with the load that the workers are generating, and so on. So yeah, essentially, well, yeah. Sorry for going.
It's really interesting because I went through similar exercise. It's just an application in financial markets, and we were hit by many of these questions. Probably one thing that when playing with the block size was also the timeout before baking a block. So that also was a figure that we kind of change it to speed up generating blocks or slow down. So that's also.
Yeah, I mean, I assume that's something that you have to do. I mean, it's not ideal. Of course, you want your system to work real time, and you don't want to have to kind of make fallback kind of options for failure, for potential failures and timeouts. But the fact is that if you want to have this system working real time, you might have to make the tough decision and put a small enough timeout value so you're assured that the results of whatever smart contract that you're running will be kind of out after a particular time, and if it's not, you can define a certain template. I have thought of that for kind of higher transaction throughput use cases. For now, I'm okay there. So I've been able to kind of achieve those numbers with below 1 second really latencies. So I'm fine for now. But yeah, that is also an option.
Yeah, really, this is nice work. Like reaching this number with this latency figures, it's really good work. To be honest.
Thanks.
I shared here just a paper from IBM. It's dated back to 2018, but I think they did very good analysis on IBM on Hyperledger Fabric performance. So probably you can find it useful.
Yeah, I've seen this paper, and I've seen a couple of more. So I think this group, they were using almost 300 cores. If I'm not wrong. Yeah, 300 something cores. And again, the problem with these kind of papers is that they don't use the standard versions of the fabric.
Correct,
they do manipulate. So manipulate for the good, right? So they are trying to optimize the system. And it's, to be honest, it's not always really easy to reproduce what they've achieved. So I've been trying to reproduce some of these, but again, you have to really go deep into the fabric and kind of try to figure out what they've done and how they've improved it, right?
Yeah. One last comment probably from my side, and I'll leave it to the others maybe. Is I see also a similar use case for this, not just for 5G, because I think one of the questions was regarding where you can apply it, is in TV white space, which is also another domain where there's like shared spectrum, and there are like users who would like to bid and utilize that spectrum, which is it's not as 5G, but it's still one spectrum where it's providing internet access to rural communities, etc. So probably you can look at it as well.
Yeah, thanks, Ahmad. Yeah, that is also one of the kind of the markets could actually that this solution could be applied to.
Yeah.
Thanks, Ahmad. We have very good question from Mark. What other DLTs did you investigate before choosing Fabric?
So we did play around with Ethereum, and I mean, as simple as kind of deploying a smart contract with Solidity and kind of the remix that they have. Having in it, at least back then, Ethereum didn't have the enterprise solution that they have at the moment when we started with this work. So really the idea of having to pay a gas price for, it's like having operators paying gas prices to some other entities to run their internal transactions with other operators just sounded bizarre to us. And so that's really one reason that we didn't use Ethereum. So nowadays, I know
sorry to interrupt, Nima. Did you use public Ethereum once you checked with the public one, right?
Yeah, back then, yeah. So back then, I mean, the enterprise Ethereum was not around, right? I know that you have the different networks and you can set up your own networks and so on, but it's still like the idea of a cryptocurrency being connected to your blockchain was not really appealing to us. Then, I mean, other options were there. Well, by other options, I mean like the option that I actually looked into was the Corda, R3 Corda. There was also another option, but to be honest, I just essentially chose Fabric because of the community and the features that was around. So yeah, I mean, I think the only other kind of blockchain platform that would be worthy of looking into at the moment would be Corda, and also the enterprise Ethereum that I haven't had really the time to go and explore.
Thanks. Thank you, Nima. Any more questions? Nima, can I share my screen? Like, if we don't have any questions, like, yeah, thanks. So, yeah,
sorry, I have one question.
So, yeah, please go ahead.
Through what I heard here, I didn't figure out that. What is your opinion about the bottleneck of this platform when you're reaching 400 transactions? What is your idea? Have you reached to a result that, okay, the bottleneck of this system is, for example, this the endorsement that you have n out of n, the availability of the nodes or something, but that because you are using a synthetic network and not a real one, so the bottlenecks
hey,
theoretically somewhere in the design.
Yeah, you're losing your sound, but yeah, I know your question, so I can just answer it. So I have almost no clue where the bottleneck is in terms of the fabric itself. But it, kind of contrary to what you said, no, I'm not really using a kind of a internal network. I am actually using a cloud network where there is latency between these VMs. So these VMs are not really on the same host, essentially, necessarily. And I think they're also, some of them are on different regions even. So the latency is there. So the network latency is there, at least to a certain point. Of course, it's the Google network that I'm using. It's the Google Cloud network. They have fiber connected between all their data centers. So that is that has to be taken under account. You can essentially go and check online the latencies between different regions in Google Cloud, for example, right? So that's one thing. So the latency between these VMs doesn't help. especially that I'm using Raft, and you have the elections, the periodic elections happening and so on, and all these orders having to communicate with each other. The other thing that I've been doing is that I've been distributing these orders among different operators, so I don't have operator clusters like different clusters for orders. So I'm not putting all the orders in the same environment. So I'm assuming that could have been a little bit better in terms of performance, but that is really a logical requirement for us to have them distributed among the organizations. So I mean, and then again, so the endorsement policy that we have is the most extreme one. It's N out of N. So all the peers have to execute the smart contract. So yeah, I mean, besides this, I mean, this is an ongoing research, so we are still trying to figure out where the bottleneck is. But this is really the most updated answer I can give you for the moment.
Thanks, Nimo, for the answer.
Yeah. So I think this is very interesting topic itself, is a slicing, network slicing. And thanks, Nima, for your talk. And I want to just say that how we use some kind of slice composition and orchestration things. And I just want to show quickly that how means we will discuss this most probably in the next talk, that how we used is this kind of things, like for example, if we have different telecom operators with SDN controllers, and if we have some kind of orchestrator, and that's what my question was, that I was planning to use this a blockchain node on this SDN controller, so that we can talk to and the main node on the with order and everything on the QoS orchestrator things. So yeah, we will talk about this. Like, I think I will ask you like maybe more questions, or I means we can discuss it, like that how we can use these kind of slicing and where we can use these kind of blockchain things over there. So thank you for your time, Nima. And I think we are over time. And yeah.
Yeah, thank you.
If we have,
sorry,
yeah.
Go ahead, Vipin.
Yeah, so I think we have one more item in our agenda today, but let's postpone it to the next thing. Nima, do you have any update on this? Like, do we get anything on this Google Doc? Like you shared the link for the last changes.
Yeah, just for the other attendees, of course you're welcome to stay on the call, but we are now kind of doing some internal things regarding the Telecom SIG. So yeah, Vipin. So I got some input from some people. They were essentially minor kind of typos and so on. I don't see anything major. So, and this was really the deadline for the latest recommendations. So if everyone agrees, I can just quickly have another round of review and then
please
send it on to David. And
great. Yeah, that was gonna be my question too, when you were ready for me to hand it off to the technical writer. So it sounds like you'll send me a note.
Yeah, exactly. So I'll send you a note. I mean, if no one else wants to really have any other kind of suggestion or comment, we can just send it on.
I think that's fair. I mean, we gave people space, 2 weeks in
4 weeks actually. So
4 weeks. Okay, yeah. Yeah. So let's wrap it up. Yeah.
Yeah. Okay.
Yeah, I think it's time to wrap up. Yeah.
Good. Perfect. So I'll just have a final look and then I'll send you the note.
Perfect. Great.
Thank you.
And I was also going to say, I will post this will go on YouTube and the Hyperledger website and the wiki. I will post a link to your recording and share it out on the list. So if anybody wants to share it with anybody else or watch it again, it will be available later today.
Perfect. Thanks.
Thank you.